Hello and welcome. Today we have something pretty exciting to talk about. If you are a nerd, you're going to be right at home. So today we're going to be talking about Alkira, of course, but we're also going to include something else. We're going to talk a little bit of Containerlab. So Containerlab is a fantastic tool that builds and manages virtual network labs. So it uses containers. It's really easy. You have basically a text-based topology file to start your lab, and you're up in Mets. So instead of having these really long manual network test beds that you have to build, you can basically define what you need in one file and then run a single command to bootstrap the entire thing. So the Container Lab kind of takes care of the creation of containers, stitching them together, and setting up that control plane. And the other thing we're going to talk about is something you might have heard of. It's called IPsec. So this is a fantastic protocol. It's widely deployed and I'd say particularly well suited for enterprise and service providers alike. It has depth and security and flexibility, but it can also be tricky and time consuming sometimes. So you have to, essentially navigate multiple phases with, think internet key exchange and IPsec. And each phase has its own set of parameters that basically have to match exactly between endpoints. And, say like a single mismatch in any parameter, it can cause an entire tunnel to fail. And with that, both sides need to be agreed. And especially when it comes to like pre-shared keys, your in-cap algorithm, and authentication methods, etc. So with me to talk through this is Ahmed Al-Odhari. Do you want to introduce yourself, Ahmed? What do you do at Alkira?
Yeah, hi, I'm a principal solutions engineer. So basically, I'm a technical expert and advisor champion for customers. Essentially, my goal is to help them achieve their business goals using Alkira and solve their, cloud challenges, cloud networking, and security challenges.
Awesome. And I guess I got to introduce myself too. So I'm William, and I work as director of technical evangelism. So talking about the technology, talking about the use cases, and doing a little marketing and technical, both product marketing, things like that. And I've had the privilege to do some really awesome work with Ahmed regarding containers, regarding coding, Python, API stuff, Terraform. So we share some of the same interests as far as like deploying infrastructure. So I guess first things first, I guess we could start out with like what on the Alkira side, how is IPsec terminated? What is an IPsec connector? Kind of how does that work?
Okay, perfect. So, as you mentioned, IPsec is one of the easiest ways to basically extend connectivity from an on-prem site into Alkira. And one of the challenges that we found with IPsec that different vendors, they do IPsec differently, and just testing IPsec can be very challenging. And setting up all these sites to simulate a branch and just configuring IPsec can take a long time, right? And if we look at you know the different method that we've done in the past, and how complex they are, and when we compare them to Containerlab, it's basically day and night. So what we've done in the past, mostly we'll just either use a physical device at home or in a cool facility and just extend IPsec to test it to connectivity into Alkira. Sometimes we've virtualized, vendor devices in the cloud, that can be really costly and it can get really complex really fast. And essentially what we're going to do is just simulate a site on-prem and just use IPsec and BGP to connect it into Alkira, right? So I'm sharing my screen right now just to show you a typical topology for connecting IPsec into Alkira. And this is just a basic topology. We're simulating two branches connecting to two different Alkira CXPs that are deployed across two different regions in the cloud, right? So here we have two Alkira CXPs. So for anyone that doesn't know anything about Alkira, so Alkira is an on-demand network infrastructure platform. it allows you to basically connect anything to anything with, consistent network across all of your endpoints. It's all about simplicity and agility, right? And in my case here in Alkira CXP is the main component of the solution. Think of it as a virtual hub that can be deployed anywhere across the globe. And it essentially allows you to connect, your on-prem locations to your cloud workloads with, integrated network and security services. So in this topology, again, as I mentioned, they have two CXVs. They're automatically connected using Alkira backbone network that Alkira built across these two CXVs. And what I want to do is just basic site-to-site connectivity, right? Again, using IPsec is the easiest way. So we support other methods to connect to on-prem locations, but the focus here is just IPsec, right?
Yeah, and IPsec is just well known. It's supported basically on everything, every piece of, whether it's a server, a network device out there. But yeah, we support a lot of the SD-WAN solutions as well.
Correct.
And, we integrate with most of them, and we have other ways of connecting on premises as well. But IPsec is just one of those, that it's just so widely adopted. It's a standard, and it's just easy to, like you said, it's very easy to deploy. Yeah, how about we start with the files? Do you want to look at the topology file?
Yeah. So let me switch to our Containerlab VM here. So, again, one of the benefits about Containerlab is you can define the whole lab topology in a file, in a YAML file, and then you can run it through Containerlab, and Containerlab will build that topology for you using container-based nodes, right? So the main component of Containerlab is this YAML file, right? And so what we've done is we created, a templatized lab topology for IPsec, right? And one of the cool features about IPsec, about Containerlab, is now this templatized topology can be shared with our team members, so they can take it, use it to deploy, the lab that we created as is, or they can just take it and extend it, right? So let me just walk you through the, the main component of that YAML file, right? So if we look at this YAML file, so as you can see, it's very simple. At the top, you just need to put the name of your lab, and it needs to be unique. So because Containerlab uses the name of the lab to create the container. And, in our case, we're using Docker runtime to, run these containers. And, if you have, so Docker basically essentially doesn't allow you to have two containers with the same name. So Containerlab will basically create the name of the container based on this. So again, it needs to be unique, right? So this is again just the name of the lab, and then in the topology section, so you have nodes and you have links. So the nodes are essentially the containers that you want Containerlab to create. So we have two containers here. So we have a Linux container running the FRR routing protocol, right? And then we have just a Linux client using the net tool. So it's just a Linux box containing different networking tools that can be used for testing connectivity and troubleshooting that connectivity. These are the kinds. So as you can see, the kind. So Containerlab supports different kinds, and the kind is basically the network operating system, right? So this can be Linux, it can be Resta, it can be Nokia, Router, or others that Containerlab supports. The image is the actual image that we're going to use for the container. And then binds is the files that we want to share from the host system to the container. So we're sharing two files that are needed by FRR. The third file, which called Bootstrap IPsec, this is the Python script that we built together, and what it essentially allows you to do, it just builds the whole IPsec config and configures BGP, and essentially configures the whole topology for us based on the variables and based on this vars file. And I can explain this a little bit more when we actually run the container lab. And then
So basically, these
yeah,
binds right here, you have these different files, the bootstrap, the Python script we wrote, the vars file, and you're basically this bind is basically going to place them on the container
correct.
to be able to be ran at runtime. Correct.
Correct. Correct. Yeah. Yeah. I'm gonna open them and gonna show you what what we've created inside each, and also how we're using this vars file, right? And then for the X or the execution, so these are the commands that Containerlab will run when the container reaches a healthy state, right? So Containerlab also allows you to run different commands at different stages of the life cycle of the container, right? So here, we're just defining an an IP address for the Ethernet 1 interface, and then we're also running this container, this Python script once this container boots up, right? Similarly, for the client, is just a client VM that simulates the LAN side of that branch or IPsec branch, and we're just running some commands to remove the default route, configures an IP address for Ethernet 1, then it just adds another default route that points to this IPsec router, right? And then in the links section, we're just defining the connectivity between this FRR router and the Linux client container that simulates the LAN side, right? And again, that's it. That's the only thing that we need to define. And with this, we can create that topology that I showed you in the diagram.
And really, this is so awesome because if you think of, I know before Container Lab, the way I was setting these up and staging these, it took a long time.
Yeah.
You're grabbing this IP from here, that IP from here. You're configuring different things on different types of firewall services. I know my standard go-to is OpenSense or PFSense. And, configuring IPsec on those is very different than configuring it on a CSR or an ASR or anything else. So just for the purpose of testing behavior and simulating like what is actually going to happen and how things are going to get routed and the different behaviors, I don't think it can get any easier.
Yeah, yeah, and this file is easy to share, and for example, if I share this with you by just looking at the file, you know exactly what the topology is going to look like, and it's easier for you just to take this, change it, and extend it, even add more nodes if you want to have and deploy a more complex topology for your specific scenario. Let me look at the other files, right? So if we look at the Python bootstrap file, so this is a Python file that essentially configures the FRR with IPsec, with BGP, and just you know it does all the mundane stuff that we don't want to do, that we don't want to configure, right? And so we are using Libras1 for the IPsec connectivity, and again FRR for the routing piece, right? And this is just a Python script that reads the vars file, and based on the information in the vars file, it will create the IPsec config, it will create the BGP, it will bring all the interfaces up and everything, right? And then for the vars file, so we've built this vars file to cater to the building IPsec specifically to Alkira, right? But this doesn't prevent anyone else from just taking this, and they can change it to basically make it work with any other standard IPsec connectivity between two endpoints, right? So here, this is just this, here we're just defining the IP addresses for the Alkira side. And, with IPsec, there are three ways to configure IPsec. So you have policy-based, route-based, and you have static route-based. So for this, we're focusing on that route-based. So we need to create basically IPsec tunnels, and then we need to define virtual tunnel interfaces, and we're running BGP across, right? And basically this vars file, asking us to define all these IP addresses. So the public IP addresses, the virtual tunnel interface IP addresses, the pre-shared key. So we're just using, predefined pre-shared key, predefined icon IPsec algorithm information, just to make it easy. So these are the default values in Alkira, and again, we can change them on the fly, right? The only requirement is we need to match these values between both sides, right? And then the BGP ASN for both the Alkira side and this Containerlab side, and then the networks that we want to advertise over BGP, right?
Do you want to pull up the Alkira UI and just kind of show off where you get this information from?
Yeah, yeah.
As everybody knows whoever knows me out there knows I hate user interfaces. I'd rather automate and do things in CLI, but I love our UI and how easy it is to actually get this information that you need to do different things.
Yeah. Yeah, so this is our sandbox tenant in Alkira. So we use this tenant to do all sorts of testing. Customers, they have their own tenant, that they can log into. So in this case, so I'm just going to look at the USE CXP. So this box represents an Alkira CXP. And as you can see, I already have connectivity to an IPsec site. I'm calling it CLab Site 1. And as you can see, the health of this site is up, right? And I have BGP and IPsec in the healthy state, right? And this is where we can get all this config, right? These configs can be, we can also get this config using RESTful APIs and whatnot. But, for now, I just basically grab this information from here, just copy and paste them into that vars file. And then I just run Containerlab, and then it will just build the IPsec really quick for me, right? And for this demo, what I've already done in the US West CXP, I've already created and configured the Alkira side. So now what I'm going to do, I'm just going to quickly run Containerlab. And so I'm just going to create a new site 2, and then I'm just going to copy this information into the vars file. And I'm going to run Containerlab, and Containerlab will build that IPsec site for me. And, the Python script will configure it based on this value. And then we'll be able to spin up a complete site in a matter of minutes to allow us to complete the testing, the site-to-site testing via Alkira. Okay, so let me switch and actually start doing that config. So what I'm going to do, I'm going to, make a copy of this IPsec lab template. And I'm just going to call it site 02, right? And then I'm going to go to site 02 here. And then also I'm going to change the IPsec YAML to site 02.yaml, just to keep the convention, the naming convention that we have here. And then so the first thing that I want to do is I'm just going to change this name. I'm just going to call it, site 2. I'm also using my name here because, my team members are using this VM to also run their own IPsec lab. So, we just add our name at the start to avoid clashing with names. And then the second thing that I want to do is just, start populating this vars file with the Alkira information, right? So, and I can do that really quick here. So let's start by getting Alkira public IP addresses. And then the virtual tunnel interface. And this one is 51. And the local VTI is so this. And for this, actually, I'm gonna advertise this prefix, and I'm just gonna change the IPs here to actually match that. Okay, so that looks good. So with that, the only thing left is just to run it. So we want to do a deploy -t and then okay, that's it. That's the only thing that we need to do. And now we just wait for it to come up. But what I'm going to also do, I'm going to log in to the FRR container. So I'm just going to log into the CLI, and then I'm just going to just run some of the commands that we use to verify the connectivity. And I think just great tools for troubleshooting that connectivity in general. And so actually, let me do that. Okay, so now I'm logged into that VM. So I'm logging into this FRR VM, right? And this is the container ID. So the first thing that I want to do is I just want to check if my tunnels for IPsec were created properly. So we're looking at the VTI 01 and VTI 02. As you can see, these got created properly. And these get created again by the Python script. So the Python script, so here it got executed and it just reads that vars file, and then it just takes that information and builds the virtual tunnels, IPsec tunnels, and BGP, right? So this is the first command that I want to run. Second command that I want to run is just to look at the status of IPsec. So I'm looking at the status of IPsec, and as you can see, I have these tunnels get created. So looks good so far. And by the way, so we are creating two IPsec tunnels because Alkira by default expects you to create two IPsec tunnels for highly availability and redundancy. So whenever you create an IPsec connectivity into Alkira, so Alkira infrastructure is highly available, and it will always create redundant tunnels, whether that's SD-WAN, or connectivity to IPsec, or connectivity using, private circuits like, AWS Direct Connect, Azure Express Route, or GCP Interconnect. So anyways, we always terminate and create redundant connectivity. So that, the connectivity was established already. And as you can see in the Alkira side, the site is already in the healthy or in the up state. So that looks good. So there are other tools that I can use, right? So I can go to the VRR context, and then we can look at the the BGP configs, right? So I can just look at BGP summary. So BGP is established, and we have messages that have been exchanged between the two peers. We can look at the BGP routes, and as you can see, I'm advertising this prefix to Alkira, and then I'm learning all these /32s from Alkira. So these are, we call them Alkira diagnostics IPs. So Alkira will advertise these prefixes to you by default, and you can use them to just verify reachability between any, connectivity into Alkira, right? Excuse me. Yeah, so this is what I wanted to do, and as you can see, we verified connectivity, we verified BGP, and now if you just do a ping to Alkira, we can also so Alkira also provides some great diagnostic tools like live packet capture that you can run to look if the traffic is coming in or outside Alkira. If you want to look at the routes and anything else. So and I can also
However, you want to open our troubleshooting dashboard up in Alkira and take a look. Just kind of maybe do some pings to the endpoint and
Yeah. So the first thing that I want to do is just show you the Alkira global route table. So as you can see here, I'm looking at the AHSG segment. So within Alkira, you can create distributed VRFs. We call them segments. These are end-to-end segments. So I'm actually connecting these IPsec connectors into a segment into Alkira, and this segment is called AH-SG. Right. So we have different segments here. My teammates are using them. So here I'm learning these two prefixes from both sites. So site 01 and site 02, right? So this is the prefix that we've advertised, as you can see here. And if I click on the actual site, I can also look at the prefixes that Alkira is advertising to that site. As you can see, these are just matching the prefixes that we're looking at in the FRR route table, right? So from here, so let me just ping one of these IP addresses, right? So I can actually, for ping to work, I'm actually gonna ping it from the LAN side. So let me just exit from here and then just grab the ID of the other container and then just do ping from there. So this is the container on the LAN side. So this container represents the LAN side. So this is the 10, 10, 11, 10, right? So I can ping Alkira diagnostic IPs from here. And as you can see, it's working. And then from Alkira side, so I can show you some of the D2 operation tools that we expose to customers that they can use to verify connectivity. So this is coming from site 2, which is connected to the US West. Let me only show my segment here. So I can click here and then I can say, you know what, I want to bring this connectivity for diagnostics. And then I can just go to flow capture. So this is live packet capture. And as you can see, I see that the ping is coming here into Alkira. And it looks like the VM is so this is ping and this is the diagnostic IPs. So the other thing that we can do here is you can some of the other tools that we expose is you can look at the health of that connectivity. You can grab the IPsec config from the Alkira side. You can do ping and source them or trace out source from Alkira. You can look at the real-time route table. So if we're making IP route changes from the on-prem side and we want to grab that route table, we can just get it from here. We can also generate a PCAP file, and that which can be downloaded and can be opened using Wireshark or any other tool to open PCAP files. And if you're using Alkira for NAT, you can also look at the active NAT translation. So these are just some of the tools that I typically use when I troubleshoot some of the connectivity to on-prem or to the cloud from Alkira.
Wow, so packet captures in cloud is a pretty it's been something that's missing for a long time. If you're going completely cloud native, that's one of the things we hear so much from so many different network engineers is, hey, we need a packet capture to do X, Y, and Z. We need to see the raw data, and for some advanced troubleshooting purposes. So this is pretty awesome. No matter what cloud you're connecting, or if you're connecting on premises and you need to grab that capture, cloud or not, we can provide it pretty easy.
Yeah, definitely. Okay, so we showed you how easy it is to actually bring up that site, and it's also really easy to clean up after, right? So now if I'm done with all my testing, what I can do is I can just come here and say, you know what, I'm done, doing all my testing, so I can just use CLab and then just destroy that topology, right? If I can spell that properly. And then, Containerlab will just go and destroy all these containers for you. And that's it. It will remove the containers, remove the files, and you're done, right? And that's it. And, after that, if you don't need this site, they can even, just remove it from here as well, right?
Yeah, this is awesome. And this is really the next iteration of, when I hear a lot of network engineers talk and we go to different conferences, like AutoCon was one specifically, and every network architect, network engineer, from around the world that's coming to these events has realized that, like, network engineers historically have kind of stopped at layer 3 and layer 4, that there's this whole area of application networking above that, this whole area of containers and service mesh, and it's all still networking. It's some reverse proxies, it's some tunnels, and it's still networking. It's just higher up the OSI model. And so more network engineers are getting more and more, I would say, pushed to learn some of these technologies, to learn how containers work, because, again, the network is the network end to end. So have you seen a lot of value yourself in kind of like learning these? And then, from testing perspective as well?
Yeah, definitely. I think what helped me really well is just having that solid network foundation, right? it's end of the day, it's networking, underneath, and having the expertise to use these tools, and and basically just use any tool that is available for you to do the job and to do it efficiently, right? And in this case, you know, that's what Containerlab allowed us to do, right? Basically, the ability to create sites really quick. And I'm also now thinking about other things that we can do with Containerlab. So we started with creating templates to create simulated IPsec sites. But I think when we've discussed this, that we want to extend it to see if we can also extend that to simulating SD-WAN sites for different vendors. Or we recently announced the ZTNA solution, and I'm also thinking of using this to simulate ZTNA users, right, from different locations. And basically the ability to create that simulation really quick is very important and and critical to allows us to move fast as well.
Yeah, and I guess like it off the top of my head, like you think, why would you even want to do that? But then you think of, okay, the network is everywhere. For most companies, you can have sites, you can have data centers, you have your campus, but then just like you said, you have users. Well, there's a huge paradigm shift with ZTNA where you have users that need to connect directly to applications in the cloud, or they need to connect to other users or to other sites. You want to shrink that attack surface as much as possible, but you have so many different combinations and scenarios that you can test with. And that's one of the beautiful things about Alkira is you have this network platform that has all these different solutions built in. And then you have tools like this that allow you to come and validate your routing, validate your behavior, validate your access, and test all this stuff very easily without installing a box, without installing a virtual appliance, without touching any of that stuff, from an end-to-end perspective. So
Yeah.
that's really
Yeah.
intuitive.
Yeah, and it's a game changer, to be honest. It's again, it's open source. It's easy. It allows you to easily share labs, to extend labs, and just move really fast and iterate really fast.
Good stuff. Well, hey, thanks for jumping on and talking through this. This is awesome. And you know what? We'll probably have to do a follow-up as this matures and we build on it and build on it and build on it and build more features in. We'll have to do another follow-up video.